Good afternoon, everyone. Today's topic is traction system. So we are going to discuss about the traction system today. So a traction system is a system which causes the proportion of a vehicle in which traction system is placed or a driving force is obtained from any means of medium like engine driver, steam driver or electric motor. Traction motor can be divided into two parts, that is non-electric traction system and electric traction system. Now we can classify the services based on the traction system. So we can further classify this system service into three parts, that is urban or city service, suburban service, mainline service.
Now we will talk about urban or city services. In this type of services, there is a frequent stop, means that there is a very small distance between the stops, nearly 1 kilometer or less. Therefore, to achieve high scheduled speed between the stations, it is necessary to have a high acceleration and retardation. This is made possible by the use of equipment developed high traction efforts. Next, we come to suburban services. In these type of services, distance between the stops average from 3 kilometers to 5 kilometers over a distance of 30 kilometers to 25 kilometers from the city terminals. In this case also, high rated acceleration and retardation are necessary. Next, we come to main line supply. In these services are used for long distance between the stations. Therefore, high balance speed are desirable. For this, modern acceleration would be adequate unless there is a large number of speed resistance. Now we will talk about speed time curve. The speed time curve tells us about the train, and their energy consumption can be conveniently studied by the means of speed time and speed distance curve. As their name specifies, firmly gives specifications of train at various time and later given speed at a various distance. There are some points that we can cover under speed time duration. The first point is its slopes give the acceleration and retardation as the case may be. Second, the area of the curve gives the distance traveled by the train. Third, the energy required for the proportion can be calculated if a resistance of the motion of train is known. So this is the final graph that we will plot in the speed time curve, and there are five time constants. The first one portion is constant acceleration period, second one is acceleration at speed curve, third one is free running time, and the fourth one is costing, fifth one is braking. As the time 0 to t1 represents the constant acceleration from t1 to t2, from here the acceleration of speed curve. The third time t2 to t3 is the free running time of the train, and the next point from time t3 to t4 is the coasting or running of the time, and the fifth last point is braking from t4 to t5. In this region the actual braking will take place. So this is the actual speed time curve of the train. In the constant acceleration period, during this period the motor accelerates from rest and current takes by the motor and traction efforts are practically constant. It is represented by the portion O to A, here to here. This is known as notching up period. Second, acceleration of the curve time, that is from T1 to T2. After starting operation is over, train start continuously to accelerate along the curve A to B. During this period, the motor current and torque decreases and the speed torque increases. As the acceleration gradually decreases, torque developed by the train exactly balances due to the resistance of the motor. Shape of a V that depends on the primary torque and the speed characteristics of the motor. The third point is free running period, which is seen in the point of B and A, that the time between the P and C is T2 to T3, and at the end of the second period, that is at T2, train attained the maximum speed. During this speed, the train runs at a constant speed attained at T2 and constant power is drawn. It is denoted by the portion B and C that you can see in this figure, in this graph. Now the fourth point is coaster or running period. This is denoted by B and C and D point, and the time duration is from T3 to T4. At the end of the third period, that is at T3, power supply is cut off and the train is allowed to run under the own momentum of inertia. So the speed of the train start decreasing on an amount of the resistance of the motion Rate of decrease of speed during the coasting is known as coasting retardation. This is denoted by the portion of C to D between T3 and T4. And the last portion is braking, as you can see, which is from D to E, and the time is between T4 to T5. During this braking, the braking is applied through the torque and represented by D to E, as there are three types of braking, as we have discussed earlier in previous classes.